Hello boys and girls, welcome to Jabulani's Playhouse. I'm Lani. And I'm Jabu, and we're having fun with our lab in a bag. These are science experiments, test tube experiments, and it's a lot of fun, isn't it? It sure is, Jabu. We've done a whole bunch of ones different so far. Well, we only did the one, I should say, right? Yeah, that's right, but we've got a whole bunch to do. I think that's what you meant, hey? That's right, we got another 4 experiments to try, so shall we get to it? I think we should. Which one do you want to choose first? Well, let's try start from the left this time, hey? Okay, sounds good. Let's get to it. Okay, and this one, as you can see, boys and girls, this was the test tube where we did the disappearing jelly ice. And this was the one here, disappearing jelly ice. We did that, and that was a lot of fun. And now we're going to choose the one on the left. And what's this one, I wonder? This is PHUN. Make your own pH indicator. Explore the science of acids and bases as you study things found in your own kitchen. Okay, Jabu, let's get to it. Okay, we have to take this out here. Whoops, there was something in there. Oh, I think these are pH strips, hey? Alright, close this up. Boys and girls know these are just little pop bottles, soda pop bottles, before they get changed into big soda pop bottles for 2-liter pop, hey? That's right, Jabu. Okay, let's have a read here then. See what this one is all about. PHUN. Make your own pH indicator. Explore the science of acids and bases as you study things found in your own kitchen. And of course, these are chemicals warning, so you got to be careful and get your mummies and daddies to help if you're following along at home, right? That's right, Jabu. Okay, from the kit, we have pH indicator, red cabbage juice powder, pipette, pH indicator strips, and test tube. You get it stuff. Okay, so we need a notebook and pencil, which we're not really following on because this is just for demonstration, right? That's right, Jabu. And we need 5 small paper cups, Q-tips, test liquids from the kitchen, including lemon juice, clear sports drinks such as Gatorade, vinegar, window cleaner, and lemon lime soda. Well, we got some of those we can do. And water and baking soda or powdered detergent. Excellent. Okay. Before you start, you will be doing real chemistry using things from your own kitchen. Be sure to keep a close watch over your adult helper. Make sure your helper knows that the liquids you will be testing, things like vinegar, lemon juice, window cleaner, and baking soda water, should be used with care. Have you ever gotten shampoo in your eyes in the shower? It stings. Tell your adult helper not to touch their eyes, ears, nose, or mouth after handling these liquids until after they've washed their hands, and wear safety goggles if you have them. Work with your helper to find a place to set up your lab where it's okay to spill a little, and to find a place to set up, where it's okay to spill a little, and where your experiments won't be disturbed by pets, babies, or other wandering adults. If your helper's eyes do get something splashed in them, they should be flushed thoroughly with water for 15 minutes. If they are still uncomfortable, contact a doctor. Okay, that's good to know, Jabu. It is. Are you ready for some fun? The explanation of acids and bases described in this kit is based on the studies and explanations of a Swedish chemist named Svante Arrhenius, who studied acids and bases in the 1890s. Other scientists have come up with different theories about the chemistry of acids and bases. You will learn about these theories in school someday. For now, if some snooty scientist tries to argue with you about what acids and bases are, just tell them, I see you are a fan of the Bronsted-Lewis definition. Let's just keep it simple, shall we? I don't want to confuse my parents. Jabu, that's funny. So what are acids and bases? I don't know, Jabu. Well, let's find out. Have you ever heard someone say H2O when they were talking about water? The H stands for hydrogen and the O stands for oxygen. Each water molecule is made up of 2 hydrogen atoms and 1 oxygen atom stuck together. You could think of a water molecule as a little Mickey Mouse face with 1 big oxygen head and 2 little hydrogen ears. Water molecules have a tendency to come apart. Scientists would say they dissociate and then come together again. When they come apart, one of the hydrogen atoms comes away from the rest of the molecule, so instead of having HOH, there is an H and an OH. In other words, there is a lonely ear and a one-eared Mickey. When there are more H's than OH's, more lonely ears than the one-eared Mickeys, scientists say the water is acidic. When there is more OH's, more one-eared Mickeys, the water is basic. But where did the extra ions, H's or OH's, come from? Some other molecules come apart when they are mixed into water. If the pieces they break into are H or OH, or act like they are H or OH, scientists say they have made the water acidic or basic. This is very interesting, Jabu, and quite complicated. It is, isn't it, Lani? There are different kinds of acids and bases. You probably already know some of them. Although all acids act alike and all bases act alike, some are stronger than others. Scientists created a way to measure how acidic or basic something is. The measurement is called the pH, which stands for potential for hydrogen. A liquid can have a measurement anywhere from 0 to 14. Something with a low pH, 1 or 2, is very acidic. Something with a high pH, 12 or 13, is very basic. Water is neutral, neither an acid nor a base, so it has a pH right in the middle, around 7. Cool, Jabu, that's good to know. There are different ways of testing whether something is an acid or a base. One way is with an instrument called a pH meter. One of the easiest and best ways, though, uses a special kind of paper that changes color when it comes in contact with something that is acidic or basic. The paper is called pH paper and has one or more chemicals on it called pH indicators. You have some pH paper strips in your kit. Are you ready for some detective work? I am, Jabu, and these are the pH paper strips, right? I think they are. Okay, let's try it. Use the pH strips in your kit to test things in your kitchen. Work with your adult assistant to find things you can use to discover pH. Here are some things you might want to try: water, vinegar, soda pop, window cleaner, lemon juice, salt water, milk, and baking soda water. Stir a little baking soda into a cup of warm water. What else can you think of to try? Once you have decided what you will be testing, write down all of the test subjects in your notebook along with your guesses as to whether they are acids or bases. To test the liquid, either pipette a drop onto the pH strip or dip a Q-tip into the liquid, dab off the excess on a paper towel, and then tap the Q-tip lightly on the pH strip. If the liquid turns the strip red, the liquid is an acid. If the liquid turns the strip blue, the liquid is a base. If the strip stays yellow, then the liquid has a neutral pH. What do you see? Write down your observations in your notebook. Were you right? How does it work? A pH indicator is a chemical that changes its structure when it comes in contact with an acid or base. When it changes its structure, it also changes color. Scientists use the color changing ability of indicators to figure out the pH of different liquids every day. You just did real science and excellent detective work. You are amazing. Jabu, that's terrific. Okay, the secret of red cabbage juice. Another way of testing for acids or bases is by using a pH indicator solution. You can try it. Fill an empty test tube with water. It holds about 50 milliliters. Pour the water into an empty cup and add half the bag of your pH indicator powder and stir well. Your powder is actually an extract of red cabbage, which contains a natural pH indicator, a pigment molecule called flavin, and anthocyanin. Pour about 2 teaspoons, 10 milliliters of each test liquid into a separate paper cup. To each cup, add half teaspoon of your red pH cabbage juice indicator. Now watch for the color changes. If the substance is an acid, such as lemon juice, the indicator should turn bright pink. If the substance is neutral, sports drink, then the indicator should remain reddish purple. Finally, if the substance is a base, like window cleaner, then the indicator should turn greenish yellow. Other things to try. Make your own pH paper strips by using your red cabbage indicator. Take filter paper or a coffee filter and soak it in concentrated red cabbage juice solution. After a few hours, remove the paper and allow it to dry. Hang it up by a clothespin or string. Cut the filter paper into strips and use them to test the pH of various household items, just as you did with pH paper strips that came in your kit. Red cabbage indicator colors. If the color is red, it has a pH of about 2, which means it's acidic, right? That's right, Jabu. And purple is also acidic at 4. Violet is almost roughly neutral. That's right. And then we get into blue, and that becomes basic. And then 10, blue-green, 12, greenish yellow, super basic. Wow, Jabu, this is a lot to try. Let's get our stuff ready. Okay, Lani. So we have just 3 glasses out here because we couldn't find all the different things, but we thought this would give us a nice sample of things to try. So on the left we have orange juice. That should be an acid, And then in the middle, we have water. And then on the right-hand side, we have a base, which is a window cleaner, right? So that should show us the different types, right? So let's see if we can maybe use, yeah, we'll be careful. So we'll break these into halves, so we get 2. So let's try the acid, which is orange juice, and the acid should turn red, right? Should turn the paper red. Let's see if that happens. I would say it does a little bit. Hey, what do you think, Lani? It does. It kind of going orange, which is going closer to red, right? Yeah. So let's put that down there and see what happens. Well, let's put that up there like so. And let's see what happens when we put it in the water. Ah, the water's kind of going bluish. You can see, which means that the water here where we live, I guess, is a little bit more basic rather than neutral, right? That's right, Jabu. That's very interesting. I guess pure water would be neutral, right? Like distilled water, maybe. Yeah, I think you're right. Okay. And now let's try this. This should also turn blue, even though it is blue, but wow, it turns very blue. You can see, hey? So this is quite basic. Wow, that's neat. Wow, Jabu, this is a good experiment, eh? It is. Okay, so what else we're going to do is we're going to take our pipette and we're going to put in drops of cabbage water, right? Because remember they said, this is a little pipette, I guess, or dropper, I should say. And I guess they said we could take the cabbage powder, which is here. Let's see if we can get it out. There we go. We've got one last little thing here with a couple of little pills in there. That'll be interesting to see what we do with that one. So we'll take this and we'll fill this up with water. Then we'll mix in half of this cabbage powder here. And it says a pH indicator powder. So let's try it. Okay, Lani, so I think we're ready here. All right, Jabu, let's do it. Now we've got our cabbage powder, which we mixed in with water. Some of it was a bit hard. Couldn't mix it too much. As you can see, there's a little bit of a firm ball of cabbage powder in there, but we'll do our best. It looks pretty dark. So let's see what it says again. Let's just to confirm. It was a good idea when you're a scientist just to confirm what you need to do. So let's see here. Okay. The secret of red cabbage juice. Alright, so pour about 2 teaspoons of each test liquid into a separate paper cup. So we just have a little bit of liquid in the paper, not our paper cups, but in our glass cups there. And then to each cup add half a teaspoon of your red pH cabbage juice indicator. So let's see, and then these are the colors it should go, if it's acidic or basic. So let's try it. Yay, Jabu! Okay, so I think this says 1 milliliter up to that little ball here to the top right. So let's try that. Okay, try orange juice first. We go from left to right like we did before. Okay, let's see what happens. Maybe add a drop more. Okay, let's swirl it around, see what color it goes. Yeah, so it is kind of going a pinkish red. So I guess that is acidic, as we know, right? Because remember here it said if it's red, a pH of 2, and 4 is purple, so it's kind of like pinkish red, so it's definitely acidic. Now let's try the water, and we thought the water was basic, right, Lani? That's right, Jabu. Okay. Add a drop more. So what color do you think that is? That's kind of reddish. It's kind of the same color, so I guess it is neutral. Not sure why it went bluish last time, but that's interesting. And now this next one, even though maybe we chose the wrong window cleaner because we chose one that's colored blue, but we couldn't help that, could we, Lani? But you can see this one's going even darker blue, so it's kind of definitely like a purpley blue. So that's definitely basic. Let's give it a swirl. Okay, and let's take an overview so the boys and girls can see it better, right? That's right, Jabu. Let's take a look. Okay, there you go, boys and girls. So here you can see the orange juice slightly pinkish. So definitely acidic. Then the water stayed the same color as the... We should put something white underneath, eh? So you can see it's definitely sort of same color of cabbage. So that's certainly sort of neutral. And then when we put the window cleaner on, you can see it's definitely got a dark sort of blue, so it's definitely basic, right? That's right, Jabu. Let's look at the orange juice again. Okay, there you go. Now you can see the orange juice color's kind of got a hint, a tinge of sort of pinkish, orangish red, so definitely acidic, hey? Yay, Jabu! That was a lot of fun, Jabu. I loved it. Me too. It was a lot of fun. It was PHUN with a PH. PHUN. Hehe, Jabu, that's right. It's a lot of fun. And it was fun science experiments with pH, which is a indicator of acidic or base, right? Exactly. We did orange juice, water, and window cleaner. There's a whole bunch of others you could try at home if you wanted to, boys and girls. You can follow the instructions. This is a lot of fun. It's a lot of cool things you can do in this lab bag, right? That's right, Jabu. We're having a ton of fun. Hope you like it too, boys and girls. Come back tomorrow. We'll do some more. We sure will. Miss you until then. See you next time. Bye-bye for now. Bye-bye.